The Subcommittee on Space and Aeronautics will come to order. Good morning and welcome to today's hearing entitled National Priorities for Solar and Space Physics Research and Applications for Space Weather Prediction. In front of you are packets containing the written testimony, biographies, and truth and testimony disclosures for today's witness panel. I recognize myself for 5 minutes for an opening statement. I would like to begin by thanking our witnesses for taking time from their busy schedules to appear before us this morning to examine the National Research Council's recommendations for the U.S. Solar and Space Physics Research Program and applications for space weather prediction. I realize you and your staff devoted considerable time and effort preparing for this hearing, and we appreciate your expertise as we consider these issues in the upcoming session of Congress. Unfortunately, our ranking member was unable to join us today, but before getting started, I did want to extend my warm wishes to Subcommittee Ranking Member Jerry Costello, who is retiring at the end of this Congress. He has been a genuine pleasure to work with, and in the brief time we've served together, I have come to admire his deep knowledge about this institution, NASA, his deep insight into the FAA, and his sense of grace. He has been a steady voice of reason, and I believe we will all miss him. Our hearing today will focus on the incredible work being accomplished by NASA's Heliophysics Division and on the important operational aspect this research has for space weather prediction at NOAA. NASA has developed and launched a broad network of spacecraft that allows researchers to better understand the Earth-Sun system. Their findings are used daily to help preserve our technological infrastructure by allowing system operators to better react to variations of the Sun. Building our knowledge in this field is essential for maintaining our way of life on Earth, as well as for improving the capability of enabling human exploration beyond the protection of Earth's atmosphere and magnetosphere. Together with a ground-based infrastructure of solar telescopes managed by the National Science Foundation, NASA, and NOAA, coordinate critical measurements into usable models that predict how space weather will affect our satellites, electric power grid, airline operators, and more. The Space Weather Prediction Center, operated by NOAA's National Weather Service, provides real-time monitoring and forecasting of solar and geophysical events and is continuously exploring new models and products to transition to operations. Today's hearing will examine the requirements for a robust space-based solar and space physics research program and discuss the application of this research for an operational space weather program. The baseline assessment in this examination will be the set of recommendations outlined by the National Research Council's Solar and Space Physics, a Science for a Technological Society decadal survey. Notably, the survey committee acknowledged the prospect of limited budgets and therefore recommended NASA stay the course on major programs under development, specifically for Solar Probe Plus. The survey committee further recommended that NASA utilize its current resources most effectively by focusing resources on those activities that will drive or diversify, realize, integrate, venture, educate the next generation of solar and space physics research. The survey committee also provides specific recommendations for our nation's space weather enterprise and provides detailed recommendations to NASA, NSF, and NOAA on how to best accomplish a robust space weather and climatology program for the future. As we enter into the next solar maximum, an 11-year solar cycle that is marked by increased solar activity, the availability of solar wind measurements in particular are essential for maintaining our way of life. As has been stated countless times over the last several years, however, we face a tough budget environment. In order to continue a robust solar and space physics program, a prudent and careful examination of the core capabilities and essential services this country needs is first and foremost on our agenda. I look forward to today's discussion and wish to again thank our witnesses for their presence. And at this time, I now recognize Ms. Edwards for an opening statement.
Thank you, Mr. Chairman, and thank you for your gracious comments of our ranking member, Jerry Costello. I know he regrets not being here, and like you, I too have learned both from his graciousness but also from his work ethic. Mr. Chairman, I appreciate your holding this hearing today to examine the recommendations for the nation's solar and space physics research program and the benefits of this research for space weather prediction. A little more than a week ago, the Sun had 2 solar events, in this case, prominence eruptions over a 4-hour time span. NASA's Solar Dynamic Observatory spacecraft captured the activity, and while the event would not affect Earth, this and other solar events days earlier led to alerts of potential high-frequency radio communications blackouts and weak power grid fluctuations. Because solar events such as these can have marked impacts on ground and space-based technological systems and services, such as GPS-related services, communications, aviation, the electric power grid, and pipelines, the nation's basic research programs have a direct bearing on protecting our nation's critical infrastructure. In August 2012, the National Academies released its decadal survey, Solar and Space Physics, a Science for Technological Society. The recommendations provided independent external input on the priorities and plans for space and ground-based solar and space physics research activities over the next decade, and on the applications of the research to space weather prediction. So I'm pleased to hear from our witness today on the decadal survey recommendations, the current activities, and future plans for the NASA program, and the operational activities related to space weather prediction. And Mr. Chairman, I'd be remiss if I didn't mention the budgetary challenges for this research. In a crunch budget environment, there are significant implications for our society if we don't continue and expand research in this area. We need to protect these R&D investments. Our assets, our quality of life, and our economic strength as a nation depend on the research. Thank you, and I yield back for the balance of my time.
Thank you, Ms. Edwards. If there are members who wish to submit additional opening statements, your statements will be added to the record at this point. At this time, I'd like to introduce our panel of witnesses, and then we will proceed to hear from each of them in order. Our first witness is Dr. Daniel Baker. Dr. Baker is director of the Laboratory for Atmospheric and Space Physics, University of Colorado at Boulder, and is professor of astrophysical and planetary sciences and professor of physics there. He currently is lead investigator on several NASA space missions, including the Messenger mission to Mercury, the Magnetospheric Multi-Scale mission, and the NASA Radiation Belt Storm Probes mission. He was a member of the 2006 Decadal Review of the U.S. National Space Weather Program and recently chaired the National Research Council's 2013 to 2022 Decadal Survey in Solar and Space Physics. Our next witness is Mr. Charles Gay, the Deputy Associate Administrator for the Science Mission Directorate at the National Aeronautics and Space Administration. Mr. Gay has served NASA in senior management positions for many years, including Deputy Director of the Office of System Safety and Mission Assurance at Goddard Space Flight Center, and as the Deputy Director of the Heliophysics Division at NASA headquarters. In addition to his experience at NASA, Mr. Gay has over 20 years of experience in the aerospace industry. Mr. Gay received a B.S. in Civil Engineering and an M.S. in Structural Engineering from the University of Maryland. Our final witness is Ms. Laura Fergione, who serves as the National Oceanic and Atmospheric Administration Acting Assistant Administrator for Weather Services and Acting Director of the National Weather Service. In this role, she is responsible for the day-to-day civilian weather operations for the United States, its territories, adjacent waters, and ocean areas. Ms. Fergione has served NOAA in a variety of roles over her career, including the Deputy Director of NWS and as Assistant Administrator for the NOAA Office of Program Planning and Integration. Ms. Fergione holds a Bachelor of Science degree in Atmospheric Science from the University of Missouri, Columbia, and a Master's degree in Public Administration from the University of Alaska Southeast. Welcome, everyone. And as our witnesses should know, spoken testimony is limited to 5 minutes each. After all witnesses have spoken, members of the committee will have 5 minutes each to ask questions. I now recognize our first witness, Dr. Daniel Baker, for 5 minutes to present his testimony.
Thank you, Mr. Chairman. Thank you, Representative Edwards. Thank you for the opportunity to testify today. My name, as said, was Daniel Baker. I'm at the University of Colorado. It was my privilege to chair the National Research Council's Committee for a Decadal Strategy for Solar and Space Physics, or heliophysics, as it's referred to at NASA. Our study was requested by NASA and the National Science Foundation. It was carried out with the full cooperation of these agencies and with NOAA. The study is national in scope, and its recommendations are directed to all relevant agencies engaged in solar and space physics research and applications. I believe that implementation of the Survey Committee's recommended programs will ensure the United States maintains its leadership in space physics and will lead to significant, even transformative advances in scientific understanding and operational capabilities. Space physics research provides new observations and scientific knowledge about the Sun and how it interacts with the planets and with the local reaches of our galaxy. Of most importance to society, solar and space physics research, observations, and modeling lets us understand the origins and consequences of the Sun's interactions with the Earth and what we refer to as space weather. Our report is one that is responsive to both of these drivers: the necessity to be innovative science field with multi-agency, multi-scale observations and theoretical tools, and a community that seeks to add value to a nation that is increasingly vulnerable to space weather effects. The Decadal Survey Committee's recommendations are also responsive to budgetary constraints. Recognizing the importance of crafting a resilient program in uncertain budgetary times, the survey report includes decision rules to guide programmatic changes should they become necessary. NASA's existing heliophysics flight missions and NSF's ground-based facilities form a network of observing platforms that operate simultaneously to investigate the entire solar system, really. The survey's first priority is to complete the ongoing program, to support this ongoing existing program and complete missions and programs in development. Our second highest priority is to implement a new integrated multi-agency initiative, which we call DRIVE, as was said, DRIVE. It encompasses specific, cost-effective augmentations to NASA and NSF space physics programs. DRIVE will bring existing enabling programs to full fruition through innovative, targeted programs, and will also support larger scale activities recommended for later in the decade. Its components are described more thoroughly in my written testimony. Our third priority is for NASA to accelerate and expand the Heliophysics Explorer program. Explorer-class missions have an outstanding record of delivering scientific results of great consequence in a timely and cost-effective manner. The fourth priority is that the committee also recommends that NASA's Solar Terrestrial Probes program should be restructured as a moderate-sized, competed, principal investigator-led mission line that's cost-capped at $520 million per mission, full life cycle cost. The first recommended new solar terrestrial probe reference target, IMAP, is to capitalize on Voyager observations to understand the outer heliosphere and its interactions with the interstellar medium. Certain landmark scientific problems are of such scope and complexity they can only be addressed with major missions. In our survey committee plan, major heliophysics missions would be implemented in NASA's Living with a Star LWS program. The survey committee recommends that they continue to be managed and executed by NASA centers. As this committee knows full well, multiple agencies of the federal government have vital interests related to space weather. Our committee is concerned about the degree of coordination between these agencies and the ad hoc nature of partnerships and the limited nature of resources. For reasons detailed in our report, our committee believes the first necessary but insufficient step is to recharter the existing space weather coordinating body, the National Space Weather Program, under the auspices of the National Science and Technology Council. Rechartering in this way may improve interagency coordination, but longer term additional resources will be necessary to ensure continuing availability of the requisite measurements. NASA research satellites such as ACE, SOHO, STEREO, SDO, which are designed for scientific studies, provide critical measurements essentially for specifying and forecasting space environment systems. However, NASA currently has neither the mandate nor the budget to sustain these measurements into the future. In the survey report, the committee articulates a vision for an enhanced national commitment by partnering agencies, NOAA, NASA, NSF, USGS, other agencies, for continued measurements of critical space environment parameters. In this partnership, we see NASA utilizing its unique space-based capabilities as a basis for a new program that provide sustained monitoring of key space environment observables. Thank you again for the opportunity to bring these issues from the NRC Decadal Survey to your attention. I look forward to your questions. Thank you very much.
Thank you, Dr. Baker. I now recognize our next witness, Mr. Charles Gay, for 5 minutes to present his testimony.
Thank you. Mr. Chairman and members of the subcommittee, thank you for the opportunity to discuss NASA's heliophysics program, and in particular, NASA's response to the Heliophysics Decadal Survey released in August of 2012. NASA's heliophysics program studies the Sun, the Earth's near-space environment, and the heliosphere, or the region created by the solar wind that forms the boundary of our solar system. By studying this interconnected system, NASA provides understanding of the fundamental space processes that occur throughout the universe and drive our connected Sun-Earth system. NASA currently operates 18 heliophysics missions that can be thought of as a single observatory, the Heliophysics System Observatory, or HSO. The HSO has produced a number of scientific discoveries over the last year alone. Voyager has taken us to the edge of the solar system, and many believe they will leave the solar system and reach interstellar space within the next decade. The twin stereo spacecraft have allowed us to view space weather events throughout the solar system, and the recently launched Van Allen probes are already making new discoveries about Earth's radiation belts. In addition, NASA continues to develop important new missions to support the heliophysics research program. The IRIS Explorer mission launching next spring, the Magnetospheric Multiscale mission launching in 2015, Solar Orbiter, a collaboration with the European Space Agency planned for launch in 2017, and Solar Probe Plus in 2018. NASA is pleased to receive the Heliophysics Decadal Survey and plans to work towards accomplishing the recommendations for our science program. As its top priority, the survey endorses NASA's current program of missions in development. The second priority is the DRIVE initiative that Dr. Baker mentioned. Its goal is to optimize the scientific return of current and future missions by establishing a healthy research environment and to also enable future missions through technology enhancements. The next priority is the acceleration and expansion of the Heliophysics Explorer program. The Explorer program has a long history of returning focused, cutting-edge science and providing tremendous value to this nation. The Decadal Committee recognized that we are operating in times of flat budgets and understood that the modest increases for DRIVE and Explorers would be achieved through a gradual rebalance of this portfolio. The survey then prioritizes science targets for 4 recommended missions in the Solar Terrestrial Probes program and the Living with the Star program. NASA appreciates the flexible nature of this recommendation. By providing science targets and leaving the detailed implementation to NASA, we can ensure that these missions are guided by the latest science and enabled by the latest technologies. Furthermore, the decision rules embedded within this survey will allow us to ensure that the highest priorities will be addressed. In addition to the heliophysics science recommendations, the survey also made recommendations related to space weather applications that are addressed collectively to the relevant government agencies. NASA recognizes the importance of the recommendations and will continue collaborating with other agencies. However, as the survey acknowledges, these separate space weather recommendations are above and beyond current funding resources. NASA and NOAA currently work together and with other government agencies on satellite development, operations, data processing, and modeling to inform space weather predictions. NASA performs research that leads to improved space weather prediction models and works with NOAA to transition these research results to operations. NASA is also committed to supporting its part of the National Space Weather Program, a federal interagency initiative established to improve coordination of space weather activities. I would like to express my appreciation to the survey chairs, Dr. Dan Baker and Dr. Thomas Orbuchan, and to the many volunteers and staff who worked tirelessly to develop this decadal survey. They have provided an effective guide for NASA to pursue the highest priority science in heliophysics over the next decade. Mr. Chairman and members of the subcommittee, I appreciate your support of NASA's heliophysics program and the opportunity to appear here today. I'd be pleased to respond to your questions. Thank you.
Thank you, Mr. Gay. I now recognize our final witness, Ms. Laura Fergione, for 5 minutes to present her testimony.
Good morning, Mr. Chairman and members of the committee. My name is Laura Fergione, and I am the Acting Director of the National Weather Service in NOAA. Thank you for the opportunity to testify today about space weather. While probably best known for our role in hurricane, tsunami, flood, and tornado forecasts and warnings, NOAA also has operational responsibilities for space weather forecasts and warnings. NOAA is the U.S. government official and definitive source of civilian space weather forecasts, warnings, and alerts for the general public, industry, and government agencies. The NOAA Space Weather Prediction Center, commonly called SWPC, operates 24 hours a day, providing real-time forecasts and warnings of solar and geophysical events to a society that is increasing its reliance on technology vulnerable to the impacts from space weather. Recognizing the importance of 24/7 forecasts and warnings, in 2005, NOAA transferred its space weather prediction program from an applied research environment to our operational environment. NOAA geostationary spacecraft provide critical observations of solar and geophysical events for NOAA space weather forecast used by thousands of customers worldwide, including the Department of Defense, NASA, satellite companies, and airlines, as you said. In fact, 80% of the DoD space weather alerts and warnings rely on GOES data. Currently, NOAA polar satellites include the Space Environment Monitor, which is a suite of instruments that measure energetic particles in the lower Earth orbit, which may impact communications, satellite operations, radar systems, and the International Space Station. SWPC also uses data from the NASA Advanced Composition Explorer, or ACE satellite, to issue warnings on geomagnetic storms. ACE was launched in 1997 with a 2-year design life and is a single point of failure for these critical measurements. SWPC also relies on the chronograph data from the Solar and Heliospheric Observatory and the Solar Terrestrial Relations Observatory missions to see coronal mass ejections, or CMEs, that erupt from the Sun, allowing NOAA to issue geomagnetic storm watches, which provide 1 to 3 day advance notice of a geomagnetic storm. There are extensive interagency interactions and planning already underway to ensure continuity of solar wind data and CME detection. NOAA is working with NASA to refurbish the Deep Space Climate Observatory, or the Discover spacecraft, to provide space weather measurements from the L1 position, which is between the Sun and the Earth, about 1 million miles upstream. Data from this location provide 1 hour of warning for a geomagnetic storm that will impact the Earth, affecting the electric power grid, satellites, GPS, radio communications, and other systems as mentioned. NOAA and the Air Force have been appropriated funding to refurbish, launch, and operate the Discover satellite to provide continuity of solar wind measurements as well as CME. NOAA is also working to incorporate cutting-edge technology under development at NASA. NOAA will continue interagency and international partnerships as well as the use of commercial services to meet these data requirements. SWPC maintains a close working relationship with its user community and adjusts its products and services to meet the growing and changing needs of these customers. Through this interaction, NOAA identifies operational data requirements and space weather prediction model requirements, which are made available to NASA, NSF, and the broader research community. NOAA transitions this research into operations as efficiently and effectively as possible. In 2011, NOAA successfully transitioned the first ever physics-based space weather prediction model into operational use. This model was largely developed by NSF and transitioned into research into operations from NASA. This model helps forecasters understand when an eruption on the Sun may impact the Earth and result in a geomagnetic storm. The NRC Decadal Survey report emphasizes the importance of space weather for society and therefore the value of work conducted by NOAA to provide services that protect life, property, and enhance the economy. This report sets the stage for NOAA to continue fulfilling its critical leadership role in space weather operations and applying forecasts and services to the benefit of society. As the agency responsible for integrating research into operations, NOAA looks forward to working with our federal partners to ensure the latest successful research is available and to be transitioned. The report states, quote, "It is critical that we develop predictive capabilities for space weather events while maintaining comprehensive measurements for nowcasting, solar wind, energetic particle inputs into the geospace," end quote. We must ensure operational needs continue to be met. The report also discusses distribution of essential operational data. NOAA believes that as the operational agency, it should continue to distribute these observations. Our nation remains vulnerable to space weather and needs more timely and accurate forecasts to help mitigate the potential impacts. The NRC report is an excellent first step and identifies critical research activities that are necessary to expand our comprehensive understanding of space weather as well as improve our nation's forecast and warning capability. The nation requires ongoing research and development that will inform operations. As such, NASA, NSF, and the academic community conduct important research and development activities that NOAA can access for its operations. The NRC report has provided critical insight into the areas that the larger space weather community and the agencies will continue to assess in the years to come. Thank you very much for your time and the opportunity to comment today.
I thank the panel for their testimony. I now recognize myself for 5 minutes for questions. Mr. Gay, given the emphasis the survey committee places on maintaining NASA's current portfolio of missions, can you provide us a quick status update on the missions currently in development, particularly the Solar Probe Plus, and what are the greatest risks to cost and schedule at this point in time, and how does the current continuing resolution impact NASA's ability to keep these missions on track? So about three questions in one.
Yes, sir. The quick status of the missions in development, and I mentioned most of them earlier in the oral testimony. The Iris Explorer mission is on track for a launch in early 2013. The next large mission is the magnetic spheric multiscale mission, on track for, it's well into development, on track for launch in 2015. It's in, basically, we're putting that spacecraft together right now at the Goddard Space Flight Center, and it's undergoing, we'll begin environmental testing very shortly for a launch in 2015. The Solar Probe Plus mission is in what we call Phase B. It's in its formulation phase. We're doing technology work. We're doing preparations for the preliminary and the critical design reviews. There are technical challenges there associated with that mission, as it is going to come within 9.5 solar radii of the sun. So thermal control systems are one of the greatest challenges there. The spacecraft exterior surfaces will see temperatures in excess of 2,000 degrees Fahrenheit, while the electronics will operate at room temperature. The Applied Physics Lab is responsible for implementing that mission, and they were also the organization that successfully launched and operated the Messenger mission to Mercury. So they're used to those hot environments. So we're very optimistic that they've got this the thermal control system well understood here. The risk to cost and schedule, we're still in the formulation phase for in particular Solar Probe Plus, and it has not been confirmed yet. Where NASA goes through all of the joint confidence level cost estimates and independence cost estimates, and determines the cost that it will take to implement this mission. That will occur in I believe toward the end of 2013, toward the end of next year, where we'll have that commitment date. And so the risks there are getting through the technology hurdles for the thermal control subsystem, the solar arrays, which are, in this case, they have to be liquid cooled. So those are the things we're watching very closely. In terms of the effect of the CR, right now we are heliophysics, or actually most of SMD is operating under the 2012 funding levels. Fortunately for heliophysics, that's annualized. When you annualize that, that's really close to the FY13 President's budget. So we don't anticipate any problems, at least for the next 6 months, in the heliophysics organization maintaining these missions on track.
Well, thank you, Mr. Gay. Ms. Fergione, the ACE satellite was launched in 1997 and is currently operating well beyond its planned 2-year lifetime, while Discover is scheduled to launch in 2014 and is designed for only 2 years mission life. How does NOAA plan to sustain critical space weather measurements after 2016?
Thank you for that question, Mr. Chairman. We already have begun the evaluation of best value options for continuing NOAA-defined requirements for solar winds and even the initiation of operational CME imagery for the post-Discover era. This will include the role of government agencies as well as the commercial sector and what they could contribute to that post-Discover era.
Now, the next question is for all the witnesses. What recommendations do you have to ensure that the nation maintains continuous space weather measurements? And how do we ensure that these measurements do not end up as the next Landsat, such that everyone wants the data but no one could afford to pay for the next satellite? Who would like to take that one first? Y'all can rock, paper, scissors for it. Or
I can at least start with your question, Mr. Chairman. One critical component is for the entire space weather enterprise to work together on this and make sure that the government agencies, the commercial sector, and also our international partners are a part of this continuous of our space weather space weather measurement. So that's critical to make sure that we continue communicating across the agencies and with our partners. And the international community has really stepped up, and so we have some good partnerships there as well.
I would add a couple things. One, I think the value that NASA brings is to better understand the fundamental physical processes involved in the way the sun behaves and the interaction of the sun with our environment. And the better we understand that phenomena, the better poised we are to understand space weather, understand and to be better able to model and predict. Along the lines of maintaining measurements, heliophysics has a large portfolio of operating missions, 18 currently, and we look at those missions not just as looking at individual phenomena, but look at those missions as they contribute to the broader understanding of the environment, of the space environment. And we have recognized the value in that. And for that reason, we are, as long as these missions are producing valuable scientific information, we want to keep them operating, and we have budgeted accordingly. We go through a comprehensive senior review process every 2 years to look at the operating missions and assess how they're performing, their state of operation, if there's any degradation, and are they still contributing to the greater good. And as long as that is true, we're going to keep those spacecraft flying.
Yeah, thank you very much for your question. It indicates a sensitivity that I think that's very important, and the steering committee for the NRC study was very concerned about your very question. And I think it's crucial that the next steps that we recommended there be taken to look at the posture of the nation with respect to key observations, modeling tools, and so forth that are necessary for an effective 24/7 space weather program into the future. I think it is going to require coordination between the many agencies that are interested in this theme, and it's going to take a much more focused effort at high policy levels to assure that we don't have gaps or we don't have failures to observe the sun and its effects on the Earth. So this is one of the key things that needs to follow on the decadal survey, in my opinion.
All right, thank you all. I now recognize Ms. Edwards.
Thank you, Mr. Chairman, and thank you to our witnesses. Mr. Gay, given the uncertainties and the stresses of the current budgetary environment, how is NASA planning to leverage the recommendations in the current survey? And in particular, I was looking at the recommendation around an expanded role for NASA in the post-Discover environment. So if you could respond to that, I'd appreciate it.
Yes. In terms of the budget stress, fortunately, the Cadle Committee recognized the environment that we were operating in and the possibility or likelihood of budget stress, and for that, and because of that, they did give us some I think very good guidance in terms of decision rules of what to do if we are faced with with problems as we work towards implementing the recommendations of the decadal survey, and we do appreciate that very much. They also recognized, when they recommended augmentations for explorers and also for the DRIVE initiative, they recognized that the heliophysics program has a lot in the pipeline right now, and those changes or those enhancements or augmentations would not be realized until sometime downstream when we can rebalance the portfolio gradually. In terms of the expanded role for space weather, as the survey committee pointed out, the recommendations for an augmented space weather capability were beyond our current scope and funding, and also were considered a lower priority than the science program recommendations that they made.
And just out of curiosity, though, if there is the next budget submission intended to incorporate the decadal survey recommendations, even if that's over some period of time?
Yeah, I believe, beginning in the 15 budget request, we would begin to see some maybe slight rebalancing, but our goal would be to achieve that over the next 5 to 10 years.
Dr. Baker?
Yeah, I would just like to point out that one of the things we did in the decadal survey was to recommend the IMAP mission. This is the Interstellar Mapping and Acceleration Probe. And this has dual use. It's both a wonderful basic science mission to observe the outer part of the heliosphere, but it also would make key solar wind measurements that would be a space weather monitoring kind of a tool. So I think there's a great deal we can do to have both basic science and operational capability. And this is just one example of the dual use kind of capabilities we talked about.
Thank you. Ms. Fergione, I'm sorry, I mispronounced your name. Fergione. I wonder if you could tell me about the accuracy of predicting space weather events, because it does seem to me that those are increasingly important in terms of our operation of our critical infrastructure. And in fact, every day, because we have more infrastructure that's impacted potentially by space weather. And so how good is the current prediction capability, and what kinds of improvements can we expect to gain with the implementation of the research recommended in the survey?
Thank you, Ms. Edwards. That is one of the components of our operational forecasting scheme, is to always validate and verify our forecasts. So we have made significant advancements in the error of when the actual event impacts the Earth. Where we were at 13 hours, our error could be anywhere within a 13-hour window. Now we've reduced that down to a 6-hour window on when we know that the coronal mass ejection will impact the Earth. So that is great strides in improving our forecast. And also the Enlil model that I talked about, the first model that we've been able to operationalize from NSF and NASA, definitely played a critical role in that. So continuing to transition those research into operations is important to advance the forecast accuracy.
But it's still not terribly accurate. So, for example, even with a 6-hour window, it would be really difficult to implement any activity on the ground or protecting the infrastructure in that kind of time frame.
So that's a 6-hour window on when it would impact the Earth, but the actual alert or warning goes out 1 to 3 days in advance. So you actually do have time in advance to take those precautionary measures on the power grid, on your GPS, and on the satellite instruments to put them into safe mode.
Thanks. And then I have 13 seconds. Let me take advantage of that. In your opinion, and this is to any of our panelists, how well do you think the public really understands the linkage between the research and the applications and their everyday experiences of just being able to power on a cell phone?
I would say that there's been tremendous improvement in public awareness of the effects of space weather in, let's say, the last 5 to 10 years, but we still have a long way to go. We still have a lot of work to do to make people understand what is the variability of the sun, how does it affect the Earth environment, and how does it bore down to their daily lives, as your question indicates. I think we have an opportunity with the approaching solar maximum to really see more frequent kind of disturbances, to put those in proper context, and to really help the public understand what to be worried about and what not to be worried about. And I think it's key that all the agencies play that role.
One thing also, as we were looking at the solar maximum and using that as a potential to increase the education and outreach, one of the emphasis is that the solar maximum is an increase in the number of events, but not necessarily an increase in the significance of the events. So an event can happen at any time, and we wanted folks to make sure that they weren't just focusing on the solar maximum and that they were safe before or after the solar maximum, because an event can happen at any time.
I now recognize Mr. Brooks from Alabama.
Thank you, Mr. Chairman. Given the deficits and debt that America has accumulated and the exploding cost of entitlement programs, the two of those putting more and more constraints on the productive side of the federal expenditures, productive being things like NASA and scientific advancement. To what extent should NASA and NOAA consider alternative means for gathering important data via commercial data buys, hosted payloads, use of research on the International Space Station, increased use of CubeSats, or other means? And that's for any of the witnesses.
I could first remark that thank you for the question. And this was a very important component of our decadal survey, was to try to look broadly at all of those alternative means. And I think we came out very strongly, foursquare, in support of a much greater diversification of access to space, tools in space, rides of opportunity, the data buys, service level agreements, all the things you talk about. And I think I can speak with great confidence for the entire steering committee that this was warmly received. These ideas were warmly received within the decadal survey context as excellent ways to make most efficient and effective use of what are known to be limited resources.
Mr. Gay?
Yes, sir. We are looking increasingly at alternative means for access to space, and in fact, most recently have selected a hosted payload in the Earth Sciences Venture Class program. The Tempo mission will be hosted on a commercial geosync spacecraft. Also looking at increased usage of the ISS as a platform for science. We'll be flying the SAGE-3 instrument on the space station, the OCO-3 instrument in Earth Science. And also there's some astrophysics missions as well that will be using the space station as a platform. Also looking at the capabilities for smaller spacecraft to provide key or real scientific or high scientific results. We are flying CubeSats, but more for educational purposes. But we are looking at the smaller end. We have a mission that was recently selected called Cygnus, which is multiple small spacecraft that will look at achieving some real groundbreaking science with very small platforms.
Thank you, Mr. Gay. Ms. Vergioni?
Thank you, Mr. Brooks. As I mentioned before, in the post-Discover era, we'll definitely have to seek alternative means and look at all the options, particularly in these budget-constrained times.
Well, I cannot overemphasize the importance of y'all doing whatever you can to become more efficient in the context, again, of the exploding cost associated with the wealth transfers and the entitlement programs. As you see from the public debate, the issues that we face in Congress are very substantial in that regard. So I appreciate your attentiveness to that issue. Now, a question for Mr. Baker. What led the survey committee to conclude that the Solar Terrestrial Probes program would be better suited as competed principal investigator cost cap missions rather than as a traditional NASA center-led mission?
Yes, we were extremely concerned as a committee and as a community about how to contain the spiraling upward costs in mission development. We worked closely with the Aerospace Corporation to examine the history of mission performance, and which we looked at the question with the Aerospace History Database, what was the evidence of which missions performed best at a given complexity level. And there was a very clear record in that that showed that PI-led cost-cap missions performed much better at a given complexity level, were considerably lower in cost. And so it was our considered opinion that making that the hallmark of the solar terrestrial probes, of making them cost-cap, making them led by principal investigators, and making sure that the full life cycle costs were going to be contained within that envelope, was the single best way we had of managing them more effectively and in a more cost-contained fashion.
Thank you, Dr. Baker. And Mr. Gay, can you please share with us NASA's view on the survey committee's recommendation?
Yes, sir. We are certainly going to look at this. I mean, it's an acquisition strategy or acquisition approach, and we have processes at NASA to make these kinds of decisions, because we do have to include factors such as workforce. But typically the strategic missions implemented by the NASA centers are traditionally the larger, more complex missions, and it's typically easier to do smaller missions on cost. That said, however, I believe NASA has been making great strides in our ability to improve our ability to estimate what a mission is going to cost through various analytic tools, as well as our ability to manage them with earned value management and detailed assessments of how things are going. So we have been making improvements, I think, really across the board, both on the PI-led as well as the in-house missions. I think the idea of making, looking at the solar terrestrial probes line as a cost-capped mission line is worth considering. In fact, we are going to consider it very closely, and look at models for managing those types of missions, so that we can ensure that they are done on cost and on schedule.
Thank you, and thank you, Mr. Chairman.
Thank you. And if there's no objections from the members, we will enter a second round of questions. Okay, and I'll lead off. Ms. Fergione, does NOAA have any plans to revamp funding for applied space weather research, given its importance as cited in the decadal survey report?
Thank you, Mr. Chairman. We were quite excited to see that the report was recognizing that additional resources needed to be dedicated to advancing the development and transition into operations. So as we look at our research activities on applied research, we're definitely hoping to see more connection and more collaboration with NASA and NSF on this research to operations.
What are the benefits for rechartering the National Space Weather Program, as the survey committee recommends Vice leaving the program as is, and what are the drawbacks? And this is pretty much for all the witnesses. And we'll start off with Dr. Baker.
Yeah, we looked at that. Thank you for the opportunity to talk more about this. It's become clear to us as a steering committee that over the last few years, the National Space Weather Program, all its elements, have increased in prominence, significance, importance to society. And it was the strong feeling as we discussed these topics that having attention at the highest levels in the executive office of the president would be very valuable, very important, and really help to coordinate across the agencies. And so the considered opinion as expressed in the survey was that at least looking seriously at rechartering at a higher level within the executive office, making sure that attention was being paid to all the multi-agency issues was probably one of the best ways to increase attention, assure that all the topics and themes were getting their due, and that ultimately we could have a more effective national program.
Thank you. I would first say I'd like to have further discussions with Dr. Baker and with NOAA and our other partners on the National Space Weather Program Council about the pros and cons. I don't feel like I'm at a point now where I know that, are comfortable either way in making a recommendation. But I do know even today, under the Office of the Federal Coordinator for Meteorology, we are embarking on development of a strategic plan for that organization, and the principal focus for that is to address the recommendations of the decadal survey. And whether it stays where it is or is recharted elsewhere, I don't have an opinion on that today, sir.
That's fair enough. So y'all two to get together and work out on it.
Yeah.
Ms. Fergione?
Thank you, and I have similar comments to that to my colleagues. It would definitely raise the visibility if that's the primary goal, but we do have quite a few activities that are already underway in our current structure through the National Space Weather Program, including, as Mr. Gase talked about, the strategic research plan that's already being developed.
I would just like to say I would like to compliment the agencies on what they've done with the present advisory and organizational structure. It's been amazing progress in the last years. I would just say that I think it is very worthwhile to talk with the Office of Science and Technology Policy, with the Office of Management and Budget, all the players on the executive side, and with strong involvement of the advisory committees here in the oversight committees here in Congress to talk about what's the best way to have the most effective National Space Weather Program.
All right, thank you. Dr. Baker, can you summarize the survey's recommendations related to the new space weather and climatology program with NASA as lead, and what led the committee to make such a recommendation?
Well, first of all, let me say that this was not strictly a recommendation. It was what we called a vision. We, as all good survey committees, we overstepped our bounds. We went beyond what we were asked to do or instructed to do, and decided to give advice of a sort where we weren't asked for it. But our vision was to think about what do we need to have an effective national operational space weather program. We have to have complete observations of the sun, the interplanetary medium, the effects at Earth. We have to have the models, the tools that are really necessary to tie all this together. This really requires an investment of more resources than are presently available in the budgets of any of the agencies. And so the vision we laid out was one that would require another $100 to $200 million per year over this next decade without doing damage to the basic science or the ongoing activities of NOAA or NSF or the other agencies. And so the vision we talked about was, if possible, we would love to have the present roles and responsibilities reinforced with more resources, but if that is not possible, then one possible way would be for NASA to take on greater basic observational monitoring of the system, have that put more into its charter and mandate, and so the fundamental recommendation we made was to have a follow-on study that looked closely at these issues and made firm recommendations. We felt the steering committee was neither chartered, as I said, nor did it have the time to do the kind of detailed development of a plan that's really necessary. And so I hope that real outgrowth of this will not be that we take the vision alone, but that we really have a much more detailed examination of all the aspects of this.
I now recognize Ms. Edwards.
Thank you, Mr. Chairman. I just want to follow along because I'd asked earlier, Mr. Gay, your opinion about expanding NASA's role, but I didn't have a chance to hear from Ms. Fergione about how that expanded role for NASA would relate to NOAA's activities. And so if you could just give me a minute.
Thank you, Ms. Edwards, for that question. One of the things with our operational mission is that we are able to rely upon our successes in our hurricane forecasting, our tornado forecasting, as I mentioned, those particular areas that we have proven success in the past, and that includes with the hurricane model in particular, the interagency modeling and the transition to research that we've been able to put into place and improve our hurricane track and intensity forecast. So a proven success, as you saw with Hurricane Sandy. And so those roles and responsibilities we believe should stay, the operational responsibilities should stay with NOAA in regards to producing those operational forecasts and warnings.
So given that, what would you see as, to the extent that NASA were taking on additional areas of responsibility, how would you see that, FIDIC?
Well, additional responsibilities, they're already doing the basic and applied research. So if they can continue to work with us on the transition of that applied research through our community modeling, that would be the ideal situation.
And so can you just explain to me, and Mr. Gay, perhaps you could chime in here, what are some of the key challenges for transitioning the basic solar and space physics research into tools that can be accessed by users and applied in the operations that Ms. Fergione spoke about?
I think some of the key challenges are validation of the models and user acceptance of those models through they do have to go through an extensive validation period, and that's typically a very hard point, and takes a lot of time and effort, and and I would defer to my colleague from NOAA to talk about what it's like on the receiving end of those, but I'm sure it's very difficult for them they build confidence in the models that they're operating using at this time, and there's a high bar, very high bar for them to accept a new model in that place.
Ms. Fergione?
Yeah, a point I will make is in regards to our requirements process. So as we look at our customers' requirements and their changing needs and increasing demands for this type of information, that's where we can then hone in on what particular model would ideally help improve our forecasts to meet those customer needs. So it's really about the requirements and also the validation, as Mr. Gay talked about.
And Dr. Baker, and as you respond, I wonder if you could also tell me the degree to which you think that there are current federal agency activities that can be coordinated or better coordinated, including funding and plans for space weather, and how effective the current coordination is.
Yeah, let me respond to or address a point that was just made here. I would say that a difference between terrestrial weather and space weather is the degree of understanding we have of the basic processes. I would say that we are far behind where terrestrial weather is as far as our understanding of the fundamental basic processes. We're being surprised all the time by what the sun does and how the Earth and the Earth's environment responds. So I think there's a much closer coupling in many respects between NASA basic research and the needs thereof and what can be transitioned into an operational state. I would say that, therefore, to go to the second part of your question, it's probably more crucial to have close cooperation between agencies in this developing field than it is where the physics is sort of cut and dried. And so, again, I'm encouraged by the fact that space weather, the necessity to understand this complex system, is making the agencies work more closely and cooperatively. I just think that there's more that can be done, and I think that my hope is that the decadal survey will be a catalyst to make this work even better, and that there will be more coordination of, let's say, the basic research, the aspirations of that research, the funding that's necessary to transition. But I think it's really going to require that all players work in an orchestrated way to try to make this the most efficient and effective, especially when we look at how limited the resources are going to be over the next years. This has to be done very efficiently and effectively.
Thank you. And, Mr. Chairman, one thing that we didn't have a chance to get actually on the record was not just the impacts to us as civilians in this environment, but what the impacts are on our critical national infrastructure that's related to national security, and the importance of strengthening what we're doing right now so that we don't have any gaps in understanding space weather and its impact, and so that over the long term that we're considering all of our infrastructure in this environment. So, thank you.
Thank you, Ms. Edwards. I thank the witnesses for their valuable testimony and the members for their questions. The members of the subcommittee may have additional questions for the witnesses, and we will ask you to respond to those in writing. The record will remain open for 2 weeks for additional comments and statements from members. On a related note, Ms. Fergione, this committee has several outstanding letters and requests sent to NOAA regarding the National Weather Service over the last few weeks. These include the mismanagement of NWS budget and funding and questions about a review of your agency's handling of Superstorm Sandy. I would ask for your commitment that these requests for information are fully responded to by the end of the calendar year. Can we receive your assurance that that will be done?
Yes, sir.
Well, thank you very much. The witnesses are excused, and this hearing is adjourned.
Thank you.